All right, what we're going to do here is we're going to solve a system of equation, or we're going to attempt to solve, and what we're going to find is there actually is no solutions. So that, I suppose we're solving in the sense that we find there's no solutions. This can happen when, when we view this in a geometric setting where each of these linear equations represents a plane, and if the planes are parallel, then there's no solution. There's other ways besides being parallel, but if all three planes don't intersect at a point, which is a unique system, or if all three don't intersect at a line, which is an infinite solution, if none of those is the case, or they could all three lie on the same plane, that's another solution. But there's other ways that you could have no solution, which would be if they all are parallel to each other. But there's other ways that it could happen. The planes could form something like this. I mean, there's a whole bunch of ways they could not intersect at a point or a line. So what we're going to do is we're going to start by constructing the augmented matrix for this system. And it's really important to do this properly. And sometimes it's easy to get impatient, but what one really needs to do is slow down, look at this, and then review, make sure it's correct. All right, in the top left is a 1, and that's what we want. That's our lead 1. But we want zeros in the spaces below those. So I'm going to take -2 and multiply it by row 1, and then add it to row 2, and put that in the row 2 position. And we'll find our way there. So why? Because I'm going to try to have a 0 below the 1 in the second row. Oh man. Okay, there we are. So pick a different color. I'll put everything else exactly the same except for that second row, which is going to change. So that'll make us 0. So I'm multiplying the top row by -2, and I'm adding. Alrighty. And then I can try to kill that 2 there, make that a 0 by taking -2 times row 1 and adding it to row 3. Put that in the row 3 position. All right. So I'm taking, so I multiply the first row by -2 and add it to the third row. So that's going to give 0. 0, 0, 1. And actually, that was sort of the point of the video, is that this last line, when I write this not this last line, I shouldn't say that. This last row, row 3, corresponds to zero times x plus 0 times y plus 0 times z equals 1. So this is a contradiction, and that's what happens when there's no solutions. There is no point, what I should say is what I mean is there's no solutions, is that the solution set is the empty set. And so you could say the answer to the problem is that the solution set is the empty set. There is no points of intersection. because when you solve these systems, what you're doing is you're finding if there is a solution, then those are the points of intersection. So this is an inconsistent system. I can just write inconsistent. Okay, so the short answer is, look, the bottom row just does not make sense if you're trying to find a solution. And so that is inconsistent. So the solution set is empty. Or it's the empty set. Okay. I don't know, I'll just keep writing. Why didn't I just write for the first time those solutions? I don't mean to say no solutions like the problem can't be solved. Actually, I just sort of want to leave that off. I don't want to imply that it can't be solved like it's an unsolved problem. It's just the solution set is empty. Okay.